going to go ahead and do a practice problem with the addition method. So here we have our system, y equals 1/2 x squared minus 2, and x squared plus y squared equals 4. So first thing, let's identify what these equations graphs are. So this first one is actually going to be a parabola because we have an x squared and our y is just first degree. So that is a parabola. And then our second equation is our circle. So now let's go ahead and think about how could a circle and parabola intersect and what types of solutions could that give us, or what number of solutions. So first one is similar to our last example. So if we had a circle and then we just had a parabola that didn't even touch it. So in that case, no points of intersection, therefore we're going to have no solution. We could have a circle and our parabola, the vertex just touches it. And so in that case, we would have 1 point of intersection, and so therefore one solution. If we had a circle and maybe our vertex was in our circle for a parabola, and in that case, then we're going to end up having 2 points of intersection. So 2 solutions. If we had a circle and maybe our vertex of our parabola was sitting at the bottom of our circle, well, then in that case, we're going to have the shared point of the vertex with our circle and these other 2 points. So that would give us a total of 3 solutions. And then lastly is if we had our circle and our parabola had looked like this. And in that case, we're going to have a total of 4 solutions because there are 4 points of intersection. That is all the possibilities we have. So now, one thing that I want to point out, because we are using the addition method for this example, but let's say that I wanted to use the substitution method because we already have our first equation as y equals. So y is already isolated. But the only thing is okay, if we plug in this expression 1/2 x squared minus 2 in for y in our second equation, we're going to end up getting a 4th degree polynomial, which when that happens, we don't know how to solve a 4th degree polynomial. We've only talked about factoring by grouping for those, but that's even only for special cases. So if that's going to result when you substitute in an expression, you get some crazy degree polynomial or equation to solve, it's best to use this addition method. All right, so the first thing is we need to check to make sure that both equations are in the standard form. So ax squared plus by squared equals c. Our second equation is, so we will leave that as is. Our first equation is not. So here's what we have right now. We have y and x's on different sides. So to put them on the same side, I'm going to subtract 1/2 x squared from both sides. And when we do, we get a negative 1/2 x squared plus y equals negative 2. So this is the system I'm working with. All we did was rewrite our first equation in the standard form. Now we're going to eliminate one of our variables. So how this is stated, it says multiply either equation or both by appropriate numbers so that the sum of our x squared or y squared coefficients is 0. Now, in the past, I've told you like, oh, it doesn't matter if you want to eliminate your x's or your y's. Well, in this case, it does matter. And that's because if you'll notice in our equations, we have a y to the first power and a y squared. So it's going to be really hard to eliminate those unless you're going to be multiplying by a y somewhere or square rooting. So it's easiest, since our x's are both to the second power, to just eliminate our x variables. So in this system, you'll notice that our first equation, we have a negative 1/2 as our coefficient. But in our second equation, we have a coefficient of 1. So in order to get this sum of our x squared terms to be 0, I'm going to multiply the second equation by a positive 1/2. And so when we do, remember I'm multiplying every term in this equation by 1/2. We get 1/2 x squared plus 1/2 y squared equals 4 times 1/2 is 2. And then our first equation stays the same. And our next step, it says to add the equations. So I'm just going to do that up here. So if I add these two resulting equations, negative 1/2 x squared plus 1/2 x squared, that's 0 x squareds. Now we have a 1y and plus 1/2 y squared. Be careful, because these are not like terms. Our y's are not raised to the same power, so we cannot combine these. So I'm just going to write this as a positive 1/2 y squared plus 1y. And then on our right-hand side of our equal sign, negative 2 plus 2 is 0. All right, so now we're going to use this equation, 1/2 y squared plus y equals 0, and we're going to solve for y. Now, we can factor, and both of my terms in my binomial have y in them, so I can factor out a y. So we're left with 1/2 y plus 1 in our parentheses. And now we set both of our factors equal to 0 and solve for y. So our first one is y equals 0. And then our second term, or second factor, was 1/2 y plus 1, and set that equal to 0. Solving for y, subtract that 1, so we get 1/2 y equals negative 1. And then in order to get rid of this coefficient of 1/2, we want to make that a 1. So I'm going to multiply both sides by 2. And so we end up having 1y equals negative 2. So here we have found values for y. Our next step is, well, we have our y's, now we need to find our x. So we're going to back substitute to find the values of x. So I'm going to use this equation, x squared plus y squared equals 4, to solve for those. So our first point that we had, our first value for y we had found was y equals 0. So let's go ahead and plug in 0 for y. Zero squared is equal to 0, so we're just left with x squared, and then equals 4. Solving for x, in order to undo a square, we square root. And remember that when we square root a value, when we're solving for a variable, we get the positive solution and the negative. So square root of 4 is 2 or negative 2. And then when we plug in negative 2 for y, we have x squared plus a negative 2 squared equals 4. Negative 2 squared is negative 2 times negative 2, which is a positive 4. In order to get this x by itself, we need to subtract 4. And we have x squared equals 0. Square root of x squared is x. Square root of 0 is 0. So now we have 3 different values for x. And so we're actually going to have 3 proposed solutions. So we have, when y is 0, we got 2, and we got negative 2 for x. And then when y was negative 2, we got the value of 0 for x. So here are our proposed solutions. Now we need to check those solutions. We can do it algebraically, and I would encourage you to try this algebraically, but I could also graph this in Desmos just like I did with the others and check if those solutions are in fact points of intersection of our graphs. So let's go ahead and look. So here I'll have my parabola as the black dotted line, and then there's our circle equation in purple. And if we highlight over here, we have negative 2, 0 as a point of intersection, 0, negative 2, as well as 2, 0. So therefore, we have the correct solutions. They all satisfy our system. So one thing I want to remind you is be sure that you draw out the different possible points of intersection between your graphs of your systems of nonlinear equations, just to help you make sense of your solutions. And it also helps you check, do I have a number of solutions that's even possible for the graphs that I have? And then also make sure that you check your proposed solutions, whether it is you're graphing them or doing it algebraically or even doing both. So I hope you find this video helpful, and I wish you luck as you're solving your nonlinear systems.